So, without further ado, I would love to introduce Kimberly Pearson, who is from Waterton Lakes National Park, who will be giving us a sense of what Kenow fire, the Kenow fire had 5 years ago and the impact it had on the park. And we're very pleased to have Kimberly reaching out from lovely Waterton National Park. So I will ask Kimberly to take over the meeting as such. Perhaps introduce yourself to the crowd a little bit, and we look forward to seeing your presentation.
Wonderful. Thank you so much, John. Good evening, everybody. It's really a pleasure to be here with the Nature Calgary Speaker Series this evening. Before I continue, just want to make sure, John, thumbs up on whether you can still see and hear me okay, and you can see my slides.
I can hear you very well, and also I can see your slide. Yes.
Okay, wonderful. Just please, everybody, if there are any issues that come up with any of that through my presentation, please don't hesitate to interrupt me. So yeah, I guess John asked me to introduce myself, so you can call me Kim. I'm Kimberly Pearson or Kim. I'm actually from Calgary originally. I spent the first 9 years of my life on the eastern slopes of Nose Hill in Huntington Hills, and I spent a lot of time in Nose Hill Park, and that really helped to ignite my connection to the grasslands that I've carried into my career, and spent most of my life and all my career in southwestern Alberta. I spent 4 years at the University of Alberta, did my undergrad degree there in environmental and conservation science, and then I eventually did a master's degree at the University of Lethbridge in biological sciences. And I've spent my entire career, my entire adult life, virtually here in Waterton Lakes National Park and area. I've been here since 1997. I started as a summer student as an interpreter with Parks Canada in Waterton. Spent a few summers following that as the park's first student ecological monitoring technician. So I was doing bird surveys and amphibian surveys, really a dream job for a student. And then I spent 10 years co-managing along with a bunch of ranchers, the Waterton Park Front Project of the Nature Conservancy of Canada, which is about 30,000 acres of ranch land that's been conserved along the private land interface of Waterton Lakes National Park. And then in 2014, I came back to Parks Canada, first managing a grasslands conservation and restoration project. And then when the Kenow fire happened in 2017, I became also the manager of our post-fire science program, and that's why I'm here with you tonight. I'll tell you all about that shortly. And now my role still includes that post-fire science program management, but also my role has expanded to include, as you can see on my title there, the Nature Legacy Program, and I'm Waterton's Nature Legacy Scientist. And the Nature Legacy Program is one of the federal government that Parks Canada helps to implement, and it involves really kind of modernizing our approach to conservation, and includes healthy ecosystems, so looking at species at risk, climate change effects, and ecological integrity. So this post-fire science program falls within that. And then it also includes landscape scale conservation, working beyond our boundaries and thinking really regionally and about conservation across the land, not just within protected areas. So a lot of collaboration that happens there. And then the third pillar of my work within that this program is supporting Indigenous-led conservation, and that is probably the area that takes most of my time these days of those three. And supporting the work of the Blackfoot Confederacy, the Blood Tribe, and Piikani Nation, especially in their work, their leadership in conservation and restoration related projects. So that would be a whole other presentation, but I'm really happy tonight to focus in a little bit on the Kenow wildfire. John, I really appreciate the invite to come and share an overview of ecological renewal following the Kenow wildfire in Waterton Lakes National Park. And I want to just acknowledge right off the start that this is a very broad and complex topic that we of course can't cover entirely, but I will provide highlights of how the park's ecology was affected, the renewal that we've observed so far over the last 5 years, and some notes of interest on Parks Canada's ecological management, monitoring, and research response. And before we begin, just want to ensure that everyone is familiar with where Waterton Lakes National Park is. So here's some regional context. I expect many of you have been here, maybe some many times. But for those of you who aren't so familiar, here's Calgary, and you head down Highway 22 or Highway 2, way down to the very southwestern corner of Alberta, and there's where you'll find Waterton Lakes National Park, about 500 square kilometers, tucked right up against the BC boundary and the Continental Divide. Also along the international boundary, we have a boundary shared with Glacier National Park, and we were the world's first international peace park between those two national parks. If you want to do some reading about that, I encourage you to look it up. It's a pretty neat model that's been replicated many times throughout the world. And I just want to note too, before I move on as well, that this presentation in Waterton Lakes National Park is within the present-day territory of the Treaty 7 nations, which are the Blackfoot Confederacy nations of the Kainai, Piikani, Siksika, and Amskapi-Piikani, as well as the Tsuut'ina Nation and the Stoney Nakoda, the Bears Paw, Chiniki, and Wesley bands. Ktunaxa Nation and Métis Nation Region 3 Association also claim Waterton as being included within their traditional territories. And the lands and waters of Waterton, known as Batomak Sikimi by the Blackfoot peoples, have been used for millennia for sustenance, ceremony, trade, and travel, and we thank them for their continuous stewardship and for sharing the land with us. So I want to begin here getting into the details of the Kenow fire with a brief overview of the fire. Some of you may have followed it on the news when it was unfolding and as it happened. But just so everyone has an understanding of how the event unfolded, it can also really help with understanding its ecological impacts, which we'll focus on tonight. So lightning started the Kenow wildfire about 12 kilometers to the west of the Waterton Lakes National Park boundary in British Columbia, late on August 30th, 2017. And for the next 12 days, the fire grew on the west side of the Continental Divide, outside entirely of Waterton Lakes National Park. And that's one of the first photographs that was taken of the fire on Kenow Mountain. That's why it's called the Kenow wildfire. And at that point, it was beyond any reasonable control. It was late in the day. It had already grown beyond the size that an initial attack crew could have controlled the fire. So over those 12 days, before it moved into Waterton Lakes National Park, Parks Canada worked really hard to prevent the fire from entering the national park at a couple of very key points. It would have likely entered the park a lot earlier if that had not taken place. We also worked hard to mount the unprecedented effort of evacuating the entire park and relocating the park's operations to Pincher Creek. And this was the first time that was undertaken in any national park in Canada. And we also prepared for the fire to enter and move through the park. And there's a photo, John, on the bottom right of some preparation work being done to protect the Prince of Wales Hotel. If you come to the park these days, you'll see it's still standing, and that's due to the efforts of a lot of firefighters, and some of whom were from Calgary. But despite our best preparations, the fire moved with incredible speed on the night of September 11th, 2017, ultimately burning 39% of the park's area. And this image shows the head of the fire shortly before it entered the park from British Columbia. Flame heights in this photo are several hundred feet above the treetops. And those trees are about, say, 80 feet tall each themselves. So you can sort of estimate how high those flames were. It was a really voracious fire at that point. And the helicopter from which this photo was taken was about a half kilometer away from the fire, but the crew inside of it could feel the fire's heat through the plastic window really readily. This next series of 3 images shows how extreme the conditions were and how rapidly the fire advanced. The forest was so dry and burning conditions so severe that small spot fires ahead of the main fire quickly developed into larger fires. So this first image was taken at 5:57 p.m. on September 11th. And I want you just to note the small newly ignited spot fire that's circled in red on the bottom right, and keep your eye on that area through the next 2 slides. This next image was taken 1 minute later, and that tiny spot fire that had begun just a minute before had already grown rapidly. And then this final image in this series was taken just 3 minutes later. That spot fire that was started by an ember blowing ahead of the main fire is now a large fire unto itself. And spot fires such as these were igniting several kilometers ahead of the main fire front. So an impossible fire to control with that sort of spread happening. And this map shows the fire's movement daily from the time it started on August 30th through to how rapidly it advanced on the evening of September 11th. So we'll take a closer look at this map, a still image of it in a few moments, but I'm going to just click on the slide here and it should play an animation if all goes well, just showing how the fire started, where it started geographically and how it moved through those couple of weeks. And I'll play it twice, so it happens sort of quickly. So we'll see if we can, oh, let's see, sorry, oops. I don't know if it's going to work here. I'll try again. My apologies. I don't know if this is going to work. Yeah, okay. I think it's telling me that no, it's not going to work. So unfortunately, I guess I can just point out that, yeah, the fire started over in this area on the far left, on Kenow Mountain, and it spent several days just growing in size on the western side of the Continental Divide, and then suddenly, and it moved this direction and to sort of to the southeast in toward Akamina Pass, and then also hopped across the border into the Tamarack Basin. Lone Lake is nearby there, for those familiar with it. And it moved on the night of September 11th very rapidly down that valley from the Tamarack Basin and then across into Cameron Valley and from there. So it entered the park in 2 different locations that night. So I apologize that that animation doesn't work. I'm not sure why, but we'll look a bit closer to, again, like I said, at this a similar map in just a moment. So very early on in the morning of September 12th, the weather shifted and slowed the fire's advance. And thankfully, no one in our community was physically injured or harmed by this fire. Decades of fuel reduction efforts and fire management planning, in addition to the on-the-ground firefighting, saved the Waterton town site and the Prince of Wales National Historic Site. The wildfire damaged or destroyed a great deal of infrastructure on park and neighboring lands, however. But Parks Canada has had a team dedicated to rebuilding infrastructure that was lost to the fire, and all the trails and other facilities that were damaged in the fire have since been reopened. And there's a look from near Crandall Mountain looking south toward the Waterton town site and the Prince of Wales Hotel, just to look at what was burned and not there. And I think it's safe to say everything that in that image that is not burned on this western side of the lakes was protected. That's why it was not burned similarly. So though there haven't been many in living memory, it's important to keep in mind that Kenow was not the first wildfire to take place here. Prior to this becoming a full suppression national park, stand replacing fire was a regularly occurring process on this landscape. And this is evident in this blended composite image of photos that were captured in 1874 on the left, 2009 in the middle, and 2017 on the right of the well-known landmark Bear's Hump. That rocky outcrop there is called the Bear's Hump, a popular hiking trail. And this photo was taken looking west from Prince of Wales Hotel. And in the 1874 and 2017 images, signs of recent wildfire are really obvious. Not so much in 2009. But this is a reminder that over the long term, wildfire effects on this landscape are more constant than they are not. And that the landscape is subject to a continual cycle of disturbance, such as fire, flood, drought, insects and disease outbreaks, for example, and then subsequent regrowth. And there are 3 key messages to keep in mind when considering ecological renewal following this fire. And we'll review these again at the end, and there will not be a quiz, but First off, the Kenow wildfire caused extreme ecological changes to take place very rapidly, literally overnight. However, ecological renewal has been underway since the ground cooled, and this process of ecological renewal will continue to unfold beyond the scope of our lifetimes and look very different than we have become accustomed to. And we very purposely use the term renewal here to appropriately convey how ecological changes may unfold, and that vegetation communities may not recover to what they were previously. Recovery is sort of the word we often go to here in these situations, but we figured that renewal was maybe more accurate term to use. And then finally, we find before us an extraordinary opportunity to examine the ecological impacts of a significant natural disturbance and to observe how nature responds. And what we learn here may be applied to other areas that are similarly impacted by wildfire into the future. So now let's explore all that in more depth. So this map, it's a little bit grainy. I apologize for that. I notice here now, but this map shows the total 35,000 hectare extent of the fire. The Waterton Lakes National Park's boundaries are shown in white, and 19,000 hectares burned within the park. So that's 39% of the park's 500 square kilometer area. It also shows the area that was affected in British Columbia to the west of the national park and the west of the Continental Divide, and also in the Alberta Crown Lands in the South Castle Valley, just on the northern side of the fire there. So wildfires of this size are not common in this area. However, the speed at which this fire moved across the landscape and at night, as well as its extreme behavior, were extraordinary. A lot of people who had spent their careers in fire up to this point were very surprised at the behavior of this fire and some of the things that it did. And this map also provides an idea of the fire's severity, a measure of a fire's effects on organic soil and vegetation. So as explained by the legend at the top, which again is very blurry, areas affected by low fire severity are in green, moderate are in yellow, high in orange, and then very high is in red. And as you'll see, the large areas of uniform high and mostly very high severity that you see on this solid red and orange areas of this map sets this fire apart from many others. And from this, we see that extreme ecological changes associated with high and mostly very high, sometimes also called extreme, severity have taken place in 44% of the park's vegetated area. And again, that was literally overnight over the course of about 5 hours. So very extreme ecological changes very quickly. And now let's take a closer look at how that appears on the ground. The fire affected large areas of trembling aspen forests, which don't typically burn as readily as coniferous forests. And this is one of those things that those fire people that had spent their careers in fire their jaws were on the ground when they saw this. The Kenow wildfire moved through the crowns of green-leaved aspen forests and consumed nearly all organic vegetation and soil material. This photo shows that a former aspen forest that was green leaves at the time of the fire, and it was almost completely consumed, as you can see here. So not something previously witnessed by wildfire experts. And this image was taken in spring of 2018. Once the grasslands had begun greening up, you can see those grasslands beyond the forest. And the lack of green within the former aspen stand shows just how much hotter those forests burned with all that extra fuel. Here's how some of those trembling aspen stands have appeared in the following seasons of growth. An abundance of aspen sprouts have regrown from the main part of the aspen clone that's underground. So many aspen forests appear to be rapidly regrowing over the past 5 years. And most of those aspen forests are intermixed within the grasslands portion of the park. Here's how the Escarin complex, looking southwest from near the bison paddock, appeared in the fall of 2017, shortly following the fire. And this image illustrates again the uniformity of the fire's high and very high intensity. And here's how that same area appeared in the spring of 2018, so just a year following. And regrowth has taken place most rapidly in the lower elevation foothills parkland ecoregion of the park than in any other. And then on the ground look at the similar area of grassland just taken this last month, shows that a lot of that grassland area, again, has regrown significantly, but there's actually a lot of bare soil remaining. You can sort of see that in the foreground of the image, some sort of patchiness. And when you look closely at it, there's a fairly significant amount of bare soil. And here's another composite image that represents how many coniferous forests have looked immediately following the fire, starting in 2017, and how they appeared in the fall of 2018 and 2019. So just following the first 2 seasons of regrowth. And despite the resilience shown by the shrub species that are present here toward the middle and the right of the image, a large proportion of bare ground has remained through those initial growing seasons. And it really doesn't look a lot different than this now. It has filled in somewhat, but there's still a very significant amount of bare ground. So this image just reminds us, again, witnessing ecological renewal in these areas will require our patience and openness to change. And we'll just linger a little bit longer in the coniferous forests. An abundance of woodpeckers are typically expected following a wildfire. They're known to take advantage of increased populations of wood-boring beetles, of course. And signs of woodpecker activity are visible on the tree on the right in this image. So this is an old Douglas fir tree that was alive and well during the fire, but it was killed by the fire, not completely consumed. And woodpeckers have been active, chipping the bark away and drilling holes into this tree. So we've seen some woodpeckers present in the area affected by the Kenow fire, but not as many as expected. And this may be linked to an early observation from post-fire insect research that's taking place here that indicates that wood-boring beetles did not respond positively to the abundance of trees killed by the fire. And it's thought that this may be due to the high mortality of insects in the wildfire, and also due to the extreme heat of the fire and the destruction of the tree's phloem and sapwood, which the beetles rely on. So this is demonstrated here in this photo, and the trees in the background on the left. So this tree here and this one. And at initial glance, it might look like the same activity has been taking place by woodpeckers on those trees, but it's actually very different process that's taken place there, and it's called spalting. And that happened actually the night of the fire. Those trees were they were so hot. The sap inside the trees was so hot that it exploded out from under the tree's bark and took pieces of its bark with it. So those sort of puzzle piece looking marks, those are all marks of exploding sap coming out of these trees. And I have to say, probably a majority of the coniferous trees that were affected by the fire have this effect going on in them, spalting. And you do not see the woodpecker activity on former conifer trees as much at all, or very, very, very rarely actually that I've seen. Also just a note that most areas that hosted conifer forests prior to the wildfire showed an abundance of regrowth in the 3 growing seasons since, of regrowth of forbs, especially. A U of L research team that's been working in the Cameron Valley has been taking the first ever examination of carbon sequestration from plant regrowth in the first growing season following the fire, or starting in the first growing season of past the fire. And they found that the area shifted from acting as a carbon source in 2017, the year of the fire, to a carbon sink by the end of the first growing season in August of 2018, as plants regrew very quickly. Very interesting work. And heart-leaved arnica, the dominant species that you can see in this photo with all the yellow flowers, is one of those species that's thrived through large areas of the park the last few years, such as the upper portions of the Blackiston Valley, which are shown here. So, and this photo shows this is a beautiful landscape to explore. And as one moves through it, we notice that there's still a lot of bare ground underneath the arnica and other plants that will continue to be filled in over time, but not fully regrown by any means yet. And as we've just seen, all areas affected by the wildfire are still host to varying areas of bare soil that are yet to be recolonized by live plants. And it's the sort of environment that invasive plants often thrive in and which can have significant impacts on wildlife and native wildflowers. I'm sure you're all familiar with the issue of invasive plants as being one of the foremost threats to biodiversity. And that's certainly the case with a huge disturbance such as the Kenow fire. A lot of worry that a lot of invasive plants would come in and really alter the ecosystem. There are about 39 high and medium priority invasive plants that are present in Waterton. Of the 1,200 or so plants that have been recorded in the national park, about 100 of them are invasive plants or non-native plants. And then, so they've had this unprecedented opportunity to gain ground in the vast areas of bare ground that were opened up in the fire. And we're working very hard with our invasive plant team to avoid infestations of species, noxious species, especially such as hawkweed, which are shown in this image, that took hold in the area of the Lost Creek fire, which took place in the northern portion of the Castle area in 2003. We really want to avoid a situation like that where thousands upon thousands of acres of land that were affected by that fire have been impacted by these non-native plants that were brought in, I understand, on contaminated equipment. So we've been very careful to avoid that sort of situation. It's not perfect though. Of course, we do still have a lot of invasive plants in the park, but our already prior to the fire well-established and innovative invasive plant management program has been responding to that depth of disturbance that had been unprecedented in the park. And they've been working to control invasive plants with mechanical and chemical control. And just a couple of examples of invasive plants that have been observed in the areas affected by the fire, and some of them have been certainly present prior to the fire, but this is the Blackiston fan that the invasive plant team is working on in this photo. And spotted knapweed has long been a big issue in that area, but it's only apparently gotten worse since the fire. The fire really opened up more ground and promoted its growth. So we've got our work cut out for us with that species, as well as downy brome, an incredibly invasive grass species, and other agronomic grasses such as smooth brome and timothy. And those agronomic grasses our vegetation ecologist often says that they are likely the greatest threat to the park's native vegetation communities, even more so than those noxious plants that are forbs. And here's a way you can all help when you're visiting Waterton to help address concerns with invasive plants. We've implemented the Play Clean Go program. This program educates park visitors and staff of the threat of invasive plants and encourages us all to clean any hitchhiking seeds off of our equipment, such as boots and bikes, before entering vulnerable burned areas. So there are boot cleaning stations and signs at trailheads, and I encourage you all to use these when you're visiting Waterton and any other place that has that program in place. It's important, and invasive plant management has been the primary way in which Parks Canada has been playing an active management role following the wildfire. And speaking of active management, in the early days following the fire, we fielded many inquiries as to whether Parks Canada would intervene in the ecological renewal process by undertaking other active management activities such as planting trees or seeding. Some people actually suggested we get collies and put backpacks on them with native seeds and let them run around and seed the ground following the fire. And then other suggestions such as salvage logging. But true to Parks Canada's let nature take its course approach, we are not undertaking such intensive management. Rather, we've been considering our primary roles to be observing and learning about how ecological renewal unfolds in today's climate, and performing targeted management activities such as controlling invasive plants where needed. We're also focusing on collaborations with over a dozen academic and other partners to support research about the wildfire's ecological effects and the ongoing renewal. And we're also leading a great deal of our own monitoring work. I'll provide examples of all of this work as we continue to move along here. So So fortunately, Parks Canada had collected a great deal of baseline data on various aspects of the park's ecology prior to the fire. And we had a very busy few seasons since the fire, collecting more ecological data, and how this is helping us to assess impacts of the fire on vegetation, songbirds, amphibians, large mammals, and bats. And this Parks Canada technician was setting up a bat monitoring station in the Blakiston Valley in 2019. Our restoration team has visited over 100 vegetation monitoring plots in 2018. And then Dr. Jenny McCune's team from the University of Lethbridge have visited many more, those and others since. And this has been to document fire-induced vegetation changes at plots that were established during the park's ecological land classification that took place in the early 1990s and 2000s. So we're really looking to data collected prior to the fire to make comparisons. And at each of these sites, the teams have been, oh, sorry, I'm just going to back up one more there. At each of these sites, the teams have been conducting surveys to determine how plant communities are responding following the fire. And there's a list of some of the information that they've been collecting at each site. And on average, about 40% of the original species present at sites affected by the Kenow wildfire were still present following the fire in the first initial years, at least. And this highlights the resilience of these plant communities, which is hopeful. It also points to an expectation of change, though. Conifer seedlings, mostly lodgepole pine, were found at just 57% of the previously coniferous forested plots assessed as of 2018. And this indicates the disturbance caused by Kenow wildfire may result in transitions from previously forested communities to grassland or shrub communities. This is one of my favorite images from the post-fire landscape. This image shows burned and unburned forests on either side of Forum Ridge, looking south along the Continental Divide between Cameron on the left and Forum on the right, those lakes. Pre-Kenow wildfire forests as seen on the west side or the right side of that ridge, reflect the environmental conditions that were present when those forests established following the last stand replacing fire or other disturbance. And in particular, precipitation volumes in the year or two following that last disturbance would have played a key role in laying that foundation for the forest that we still see there. So in areas recently burned with high to very high severity, such as on the east slope of Forum Ridge, on the left of this photo, we expect vegetation communities to establish that reflect climate and soil conditions the previous few years, the initial few years following the fire. And so what we've been seeing here over these last 5 years are the fascinating beginnings of newly configured vegetation communities that will take shape continually through time. And this image shows a portion of the 2003 Lost Creek fire area, about 37 kilometers northwest of Waterton. And this photo was taken in 2019. 16 years after that fire had taken place, there were some conifer seedlings present, but they were taking hold at an exceedingly slow rate. The person that took this photo told me that he really had to search through the vegetation to find any baby trees, little seedlings. And this is consistent with the findings of a recent Western US study of warmer, drier climate effects on forest resilience, where forests regrew at 85% of previously forested sites that burned prior to 2000. But since 2000, forests regrew at only 70% of previously forested sites that had burned. So conditions are becoming too dry and warm for forests to take hold following disturbances such as wildfire. And this is challenging our ideas of how vegetation communities succeed one another. This also means that some of Waterton's hiking trails may remain less forested into the future, and it provides us opportunities to experience new viewscapes, as well as a need to prepare for hiking in more exposed terrain. So make sure you come prepared. There's not going to be much tree regrowth in some areas, especially on our hiking trails, for quite some time. On a more colorful note, perhaps a more hopeful note, profusion of grassland wildflowers was expected following the fire. A lot of people were talking about that right away. Wow, think about all the flowers that are going to show up. And sure enough, that has taken place in a number of areas. And this is an example of that. This is the Blackiston Fan, the same area where the weed crew was working earlier there. And Prince of Wales is in the background. And this was taken in 2017. So the year 2017, the Blackiston Fan was a hot spot on social media. A lot of people were coming to Waterton just to take photos of themselves in this field of amazing wildflowers. And that profusion of those same flowers has not been the same since I said 2017. This was 2018, the first growing season following the fire. So this has not looked quite the same since 2018. This was a real treat in the season following the fire that we haven't seen in that location since, but there have certainly been amazing displays of flowers elsewhere since. And in all the time I've spent exploring the fire-affected landscape over the past 5 years, this is one of my favorite stories. Soon after the fire, I found several instances of red squirrels having survived the fire in their underground middens, which was very surprising given the fire's really extreme intensity in these conifer forests. One would imagine that all the oxygen possible would have been sucked out of their spaces in the ground. But they've surprised us, and by finding the areas that look like this, where there are holes in the ground, they're mounds and they're middens, surrounded by remnants of cones. That was a strong indication that they had survived underground, so had their cone caches, and they had brought them up above ground to consume them. And though the squirrels soon moved on, they didn't last terribly long in those bare forests. Their uneaten seeds of various tree species may have provided a new start in these areas for those tree species like Douglas fir and Engelmann spruce, for example. And their seeds, the seeds otherwise, if they had been left above ground, would not have survived, or all those seeds that were above ground did not survive. They were consumed entirely by the fire. But these squirrels have provided an important service by having cached those cones, brought them up above ground. And as you can see, here are a collection of cones that I found that a squirrel had brought above ground and eaten some of them, but was either back underground for a bit or maybe had been preyed upon. But there are lots of seeds visible there in the cones still, and some on the ground as well. And I have been struggling to find time to do this, but I'm really looking forward next spring, or maybe even yet this fall, to go out to these same sites and just explore whether there are tree species other than lodgepole pines, which are the most abundant tree species that are growing in the post-fire environment, and see if any of those other species are actually thriving there as well. And I think if they are, have been due to these red squirrels. Really fascinating. And also interesting is that a fungus survey has been conducted here by mycologist and University of Calgary professor emeritus Suzanne Visser, who Suzanne, I've seen your name on the list of participants tonight. It's really a pleasure to cross paths with you here. So Suzanne's work has revealed many species of fungus growing, including in those heavily burned areas in the park. And I've learned from Suzanne that many fungi lie in wait underground for many decades and sometimes even centuries for a fire disturbance to come along, and that's the environment that they thrive in, putting fruiting bodies up above ground. So I was thinking about that a little further today, earlier today, that some of the species, and Suzanne can correct me if I'm wrong, or maybe add to this when we get to our discussion time, that some of the species that have been visible above ground, it's probably several hundred years between fires in those spaces. And if they're very fire dependent species, it'll be several hundred years between times when we have the opportunity to see them above ground. Fascinating. Another interesting study and project that's taking place is the Mountain Legacy Project based out of the University of Victoria. And some of you may have heard of this before. If you haven't, I encourage you to check it out. I've got the website explore.mountainlegacy.ca noted there. So this project explores changes in Canada's mountain landscapes through the world's largest collection of systematic, high-resolution historic mountain photographs. Most of those photographs were taken by surveyors in the early 1900s, and there's an absolutely massive and growing collection of repeat images. And the Mountain Legacy team made its way back to Waterton in July of 2019, 21, and 22 to photo document the Kenow wildfire's effects on the landscape. And there's an image of one of their team members on Blackiston Mountain looking eastward along the Red Rock Valley, Blackiston Valley. So approximately 200 photographs have been repeated so far in Waterton at about 30 different stations. And this is the first time that the Mountain Legacy Project has captured third view images, so second repeats of the original photographs to create sets of 3 recurrent images over time, over the span of over 100 years. So here's an example of one of those sets of 3 images. This is the original 1914 photograph captured at what's called the Blackiston Mouth Station. So this is on the Escarin complex looking west into the Blackiston Valley along where the Red Rock Parkway is nowadays. And that mountain in the center of the image, that's Blackiston Mountain, the tallest peak in the park. And the effects of the recent fire are visible in this image on the slopes of Crandall Mountain on the left of the image. And there's also a human trail visible in the foreground, really, really obvious in this image. And I should point out too that there is no Red Rock Parkway in this image at the time of its taking in 1914. And here's the first repeat photo that was taken in 2004. There's no apparent sign of recent fire or human trails. The human trail that was in the foreground, but the Red Rock Parkway is now present in this image. And here's my unofficial repeat photo that I took in October of 2017 before the Mountain Legacy team was able to get on the ground here. So this is only a month following the fire. So fire has returned. The trail visible in the original image is now visible again in the foreground, looking very different. The Red Rock Parkway is very, very obvious in this image. And also on the left of this image, on the far left, you can see a lot of what looks like smoke, but that's actually ash blowing around. There was a lot of ash that blew around following the fire because of the very high winds that following fall. So a lot of the nutrients that usually stay on the landscape following a fire and really fuel plant regrowth, for example, actually blew away and were largely removed from the landscape. So speaking of wind, John, we were talking about wind earlier. Definitely a factor in Waterton. And finally, here's the 2019 repeat. I said this was a set of 3 images, but I guess I made it 4 with that extra one, that last one. But here's the 2019 official repeat of this photo. So this was in the second season of renewal following the wildfire. And again, there's a beautiful profusion of wildflowers, a lot of that white in the grasslands there, that's yarrow, common yarrow. So these and all these fascinating photographs that are collected as part of the Mountain Legacy Project will likely be used well into the future by many park managers, various scientists to examine things like vegetation community changes and other aspects of the constantly changing landscape. And there is a Waterton and Kenow wildfire specific webpage being built on the Mountain Legacies project's webpage. So I encourage you to keep an eye out for that if you wish, but for now, these images are available to view and peruse, not just in Waterton, but all through the Canadian Rockies. Really interesting website if you have some time. So we've focused so far on how the park's vegetation communities have responded within the post-fire environment, but now let's just make a quick shift to some of the wildlife that they support. And this photo shows, as a transition, a wildlife trail that I came upon in the spring of 2019. So this was following one post-fire growing season. And the vegetation that was compacted along this wildlife trail in the center of the image, it didn't burn as heavily during the fire because of that compaction and less vegetation actually growing on the wildlife trail. And I should just note, this is parallel to the Red Rock Parkway, a wildlife trail that's not far off of the parkway, and we're looking toward Red Rock Canyon in this image. So I found it really interesting that wildlife trail regrew so readily in the first season following the fire, in grasses where the area immediately adjacent to it didn't regrow as much, and just shows what was happening during the fire. A really interesting intersection of wildlife, vegetation, and fire. And this set of photos is really interesting as well. This is a photo of a bear that we called Bear 14. She was a sow black bear who spent a lot of her time around the Waterton town site area prior to the wildfire and following as well. And we call her Bear 14 because she has a tag in her ear. You can see that in her right ear. And she was inadvertently caught in a bear trap. We were trying to catch another bear that was getting into mischief around the town site. She got in there. We didn't put a collar or anything on her, but we just give her an ear tag, so we got to know her, who she was. And these images were both taken from a remote wildlife camera near Cameron Falls. And when I set this camera up, I didn't realize that this was a bit of a bear rub tree, at least for Bear 14. It's her rub tree. And she was the first bear that showed up in that left-hand image in 2015 after I'd set this camera up. And she walked down the wildlife trail that was adjacent to the tree, sniffed this tree and stood up and gave her back a good rub on the tree and kept on going. And she was also the first bear to show up on the same camera on the right side image following the Kenow wildfire. You can see evidence of the fire in the background. She did the exact same thing. She walked down the trail, the same thing, sniffed the tree, stood up and rubbed on it. And I find it really ironic that her pose is so similar, same bear. And again, just demonstrating the resilience of nature, of wildlife in this example. So a lot of resilience seen in wildlife following the fire, but definitely a lot of extreme impacts on wildlife as well, a lot of direct mortality because of the fire's rapid movement and extreme behavior. So there were ground and helicopter patrols completed by Parks Canada, a wildlife specialist team and other staff just immediately following the fire for a couple weeks after. And at least 40 large mammals were seen to have perished in the fire. And that wasn't a complete count. There's potential that there were many others as well. But because Waterton is part of a greater ecosystem, the crown of the continent ecosystem that spans portions of the Rocky Mountains within BC, Alberta, and Montana, it remains one of the most intact and functional ecosystems in the world. So because of this, it's a healthy ecosystem. We've had healthy wildlife populations that helped to make our wildlife resilient to the short-term impacts of the Kenow wildfire. So healthy regional wildlife populations have remained intact and are still in the process of recovering from the losses that took place during the fire. There's a really neat wildfire video that actually includes that Bear 14 rubbing on that tree. It's a series of images taken by that remote camera. I won't play it here for you, but I encourage you, if you're interested, go on YouTube and do a search for Waterton wildlife and fire, just those 3 words. It should be the first video that comes up, and it's a really interesting time-lapse compilation of a bunch of remote camera images that, like I said, include that bear, but also includes images of the fire happening right at that camera. That camera did not burn in the fire. It got very hot. I think 58 degrees Celsius was the hottest it got to without being destroyed, but captured some really interesting images in the days following the fire too of wildlife. Just a few other images of wildlife here. There's a moose moving through a burned area just shortly after the fire. We saw a lot of wildlife moving through the burned areas in those initial days. And the fire revealed a great deal of glass that had been disposed of across the landscape over many decades. much of it was broken and posed quite a hazard to wildlife. So we, in the springs of 2018 and 19, we took advantage of that opportunity to remove as much of that debris as possible with the help of volunteers. And just a note here too, that we have a lot of volunteer opportunities in Waterton. And if anybody's interested, please feel free to visit Waterton Lakes National Park's webpage, and there's a volunteer specific page. And if you're interested too, you can send an email to the email address noted here, and you'll become part of the volunteer newsletter distribution email list. And you can hear about volunteer opportunities, similar opportunities, not necessarily the same one, but a lot of really neat work that our volunteer team is helping us with. Some of you might recognize that is a gallium sphinx moth caterpillar. Hundreds of thousands of those caterpillars have been observed in areas that have profusions of fireweed since the fire. They feed on fireweed, and then they in turn are fed upon by lots of bears and birds and other predators. So really interesting observation in the insect side of things. And I figured I'd show you this photo. I know there are a lot of birders in the group. This is a juvenile western meadowlark, so typically a grassland species, but it was observed at a day use area called Little Prairie in Cameron Valley, which is a subalpine valley, but this was just shortly following the fire and the couple weeks following. So a little bit confused and not something we would have expected to see in that area, but this little bird provided a good reminder to us to be open-minded and to expect the unexpected when it came to looking at the impacts of this fire. And I'm just going to skip through, I think, a bunch of slides here because I think we're running a little bit long, and I'm sure you want to get to discussion and just wrapping up. So I'll just quickly note what we're looking at here. There's a western toad, lots of amphibians observed in areas affected by the fire, and our work in monitoring them has shown that we haven't lost them at sites. They've been resilient. There's a long-toed salamander, similarly in an area heavily affected by the fire. And those of you who know the story of the long-toed salamander crossing structures near the Waterton town site, it's a roadway mortality mitigation system where there are tunnels under the road, directional fences that were originally made of plastic that would direct salamanders into these tunnels so that they wouldn't get hit on the road. And the fire destroyed all of those plastic fences. Amazingly, as you can see in this photo, didn't destroy the wood sort of interfaces between the tunnels and the fences, but went along and melted all that plastic into the ground. So we spent a lot of time, had a lot of volunteer support to shovel it all up, and then we promptly rebuilt those fences in 2018, just the following year. And we ended up using guardrails from the parkways, the Red Rock Parkway and the Kamina Parkway, that had been damaged in the fire, so they couldn't be used any longer for human safety purposes, but they were just perfect for long-toed salamander safety. So those are the new directional fences in that crossing system. Gone from protecting Waterton's visitors to protecting some of our smaller important creatures. And a quick image here too of Cameron Falls, and just a few words on the aquatic side of things. A lot of sediment flowing into the waterways. This was in 2018 during spring runoff. A lot of sediment running off and material off the landscape. And that happened twice in 2018. And with that sediment, a lot of elevated nutrient levels are also in the waterways, so including phosphorus, and causing a lot of elevated plant productivity in the creeks. So some of the creeks and water bodies are looking a lot darker these days with some algae growth than previous, and that's to be expected and will be reduced over time. And a quick note too that we're working with the University of Alberta research team, the Southern Rockies Watershed Project, is assessing impacts of the fire on various aspects of the aquatic ecosystem within and downstream of Waterton Lakes National Park. So just a quick summary, I'll just review those key messages that we saw earlier on, that the Kenow wildfire resulted in extreme ecological changes in Waterton Lakes National Park and the other areas that it impacted. However, ecological renewal has been underway since the fire took place, and it's unfolding differently than we may have expected historically. But that finally, intriguing opportunities abound to observe nature's resilience and how vegetation communities are configured under current conditions, and that we're collaborating with several partners, as noted, to examine the fire's ecological impacts and observe how nature is responding. And what we learn here will hopefully be applicable or applied and taken as lessons for other areas that are similarly impacted by wildfire into the future. And we know that a lot of that is happening these days. So we're really hoping that this concerted effort to understand these effects of this very extreme fire in Waterton will help others learn and hopefully prepare and respond appropriately in the future. So despite the huge changes that took place that night in 2017, Waterton Lakes National Park remains a very special and very beautiful place. And there's a lot of exciting work underway to observe and understand how ecological renewal is unfolding. And I encourage you all to visit the park as you're able, to witness these processes for yourselves, and also to follow along on this journey. We'll be sharing information on our post-fire science program through our website. And we're also hoping to host some presentations by researchers that have been taking really deep dives into this, the post-fire ecology happening on the landscape, as I've noted some of them here, but there are others too. So thank you very much for your interest, and I hope that you all have a restful winter, and suggest keeping these glacier lilies in mind. They held tight underground during the fire and through the following winter, and they were the first plants to pop up happily the following spring, so an inspiring example. With that, I'll wrap up and say I'm happy to answer some questions now and stay online as long as people are interested. Thank you. I'll just end my slideshow here.
Great. Thanks a lot there, Kimberly. What a great presentation. And encouraging as well, basically showing that life does exist after a fire. And it's going to be magical watching how the landscape changes and adapts to the whole process. So we have had some questions popped up, but I encourage others who may have a question for Kimberly to place them into the chat, and then we can try to answer them or Kimberly can answer them as best she can. So the first question was the fire naturally started or by people? And I believe you mentioned it was a lightning strike.
Yes, that's right. Oh, I'm just realizing I will stop sharing my screen. Has that happened now?
Perfect. Okay,
great. Yes, it was a lightning strike. That's correct, on Kenow Mountain. That's right, in British Columbia. Mm-hmm. A lot of lightning happening these days, and I heard that with every degree of warming of climate, we can expect 10% more lightning strikes, more thunderstorms, more lightning, so more ignitions of wildfires likely into the future.
So the fire return period would be a lot shorter, I guess, throughout the park.
Yes, that is exactly it. Mm-hmm.
You mentioned a very interesting phenomenon where the sap in the wood gets superheated and explodes. The question was, what was the name of that fascinating process?
Yeah, it is very fascinating, isn't it? It's called spalting, spalting.
Spalting.
Yeah, I'll just type it into the chat. And a new term for a lot of people. It's not something I had ever heard of before.
Okay. Are the salamanders in good numbers, but the barriers? And I guess overall, just how did the amphibians survive so well? How did they actually survive?
Oh, that's a really good question. Okay, so Are the salamanders in good numbers by the barriers and tunnels? We haven't taken a real scientific look at it. So really all I have to provide you as a basis for that answer is anecdotal, but we have seen several long-toed salamanders in the Linnet Lake area. So indicating that their population is still present, and that they're in the lake breeding still. So that's a really good sign. But we're actually hoping for a researcher to come and have a graduate student perhaps do some in-depth work in looking at the population and really documenting as best we can a sort of a post-fire estimate of long-toed salamanders at that site. And then the second question, how did the amphibians survive so well? I guess we'd have to ask them really, but I anticipate a couple different things. So a lot of sites, of course, where they were are wet. So a lot of there's a lot of difference, I guess, in some areas that were wet versus not. So that moisture could have made a huge difference for those that were, say, in water bodies or nearby water bodies at the time of the fire. Also, the fire happened in late summer, so a lot of amphibians had already moved away from the ponds. So with long-toed salamander specifically, they go deep under the ground for the winter, and it was extremely dry when this fire took place. So a lot of the salamanders, I think, were already well underground at a depth where the fire wouldn't have affected them directly. But again, that effect of all the oxygen being pulled out of those spaces underground, like I was mentioning with the squirrels, you would have expected for there maybe to be some impacts of that. But if the red squirrels survived, the long-toed salamanders probably did equally as well in those underground spaces. So kind of amazing, I would say. Yeah, so those are just some ideas, I guess, on how amphibians would have survived, but definitely some mortalities. I just want to acknowledge that too, just like the other wildlife. Lots of mortality of smaller creatures as well, including amphibians.
Great. So a question is, what soil changes did you see? Have there been more landslides, for example?
Loving these questions. Thank you. All really great questions. Soil changes. So we haven't had anybody researching in depth about soil changes following the fire. If anybody knows a soil scientist who wants to come to Waterton and take a closer look at that would be great. But just sort of more anecdotally, I guess, hydrophobic soil is a phenomenon that takes place following a fire, where the chemistry of the soil has been altered to the point where water does not absorb into it. So that can last a year or two. And we did observe some of that in some areas. So some pooling of water on the land where normally there would not have been, that would not have been the case, and the water would have just absorbed down deep right away. Also, like I mentioned earlier on in the presentation, really high severity effects on organic soil and vegetation in those high and extreme severity areas. So a lot of very, very significant amounts of organic soil were removed entirely from the landscape during the fire. And in some cases, quite stark, quite startling depths that were removed of the organic soil. And then also, like I mentioned, I guess the ash that some of those soils and the vegetation had been reduced to blew away. So that wasn't present to help renewal. And then there was another part of your question, Linda, about landslides. Not so much landslides, but some rock fall. I guess the fire was so hot that there are places where you'll see a rock that was shattered due to the heat of the fire. So some weakening of rock, and including some high up above the Red Rock Parkway. And there's been some mitigation fences put in above the Red Rock Parkway to protect the roadway from falling rocks that were weakened in the fire. And then avalanche, I guess, is something similar to landslide, a little different, but on the slopes of Bertha Mountain on the backside of the Waterton town site, there have been a couple of avalanches since the fire over the last few winters that would likely not have taken place otherwise, and other places in the park as well. There's a really big one up along the Yakamina Parkway toward Cameron Lake. So lots of changes on the mountainsides, but no landslides per se so far.
Alan has a question. Do the changes in the trees result in more nesting opportunities for bats, for example?
That is a really cool question, Alan. I would say that we've actually had a bat researcher doing some work in the park, and I have not heard her final results. So I'm looking forward to doing that shortly. We're actually holding an internal symposium where we're gathering all the researchers that have been involved in this post-fire science work together for us park staff to hear their results. And so I'm going to get an update on that soon, but I would imagine that because they were, there may be spaces in some of those trees for roosting bats, but really not a lot of cover in those areas. So they're very hot or very exposed, where they might prefer, more intact forests and sheltering opportunities. So yeah, that's a really good question. I think from what I recall hearing from preliminary work of this bat researcher from University of Calgary, Erin Lowe, she was a graduate student. She was finding that all the bats she was tracking were actually roosting in buildings in the Waterton town site. So she wasn't finding a lot of bats roosting out in natural environments in the park, which I think was frustrating to her because she was trying to answer that same question that you're asking.
Excellent. So we have a question about you always mention, of course, the extreme heat of the fire in various places. Would that be accountable or accounting for the great difference you're seeing in the renewal of the environment that you might otherwise not see in a more moderate fire?
Mm-hmm. Yeah, really good question, Lenora. And yes, I would say that was a really big factor in it. The really extreme heat caused really, really significant changes. And yes, very, very sudden significant changes, and yeah, very high severity impacts of that high intensity fire. And yeah, like some variation, like you saw in that photo I showed of the wildlife trail that had been compacted. And so little things like that made a difference. It could, in some cases, made quite a difference, as you could see, like that trail hadn't been burned as heavily as the surrounding area, so that heat was a big factor. Removing all that fuel and causing very significant changes to the organic matter.
You have a question. Yeah, Bear 16 was featured in your little presentation. Ellen would like to know overall how did the grizzly and black bears numbers use and numbers of since the fire?
Yeah, good question. So we haven't done quantitative research on this. We don't have solid numbers on grizzly bears and black bears, but often that's been seen elsewhere. Grizzly bears often come into areas that have been burned, and black bears, whereas there may have been black bears sort of the dominant bear, more common bear, they typically get displaced. We have seen some grizzly bears, but maybe not as many as we would have expected, given that this is a different ecosystem than where that other work has been done. So it's Waterton specific situation. But in the first, for those of you who have visited Waterton, you might know it as a place where black bears are really abundant. You can see black bears quite commonly around the town site, and the Waterton Valley and the Red Rock Valley particularly. And in the couple of years following the fire, a very interesting thing we observed, and we were expecting this, that because there were no berries in those areas, the bears moved we think, beyond the park boundaries, outside the area that was burned at least, to take advantage of the berry crops that were intact. So there were a couple of seasons of very quiet bear activity. There weren't a lot of bears around. Bear 14 stuck around for the most part, but she also, because she had a tag in her ear, we know that she was at a ranch in the surrounding landscape for at least a little while with her cubs that one season. So she had moved from the town site outside the park to look for food. Really interesting pattern. But then as soon as the berries showed up on those shrubs that had regrown within a couple of years, the bears came back, and there's still a lot of black bears around. Fewer grizzly bears, but some. I hope that helps answer your question.
Great, thanks, Kimberly. Just looking through here. Oh, I guess how did the town site survive?
Yes, really good question there. So the town site survived because there was a lot of foresight and a lot of effort put into planning and actually moving forward with a plan to protect it over the course of decades. So starting decades ago, our fire management officers started clearing an area behind the town sites, or the interface between the town site and the forest, thinning out the lodgepole pine trees, removing shrubs and fuel on the understory, but then also thinning the forest so that there wasn't a continuous canopy for fire to move really readily through that buffer kind of area. So that was one really key thing, and that made a huge difference. And then also there were firefighting efforts in place along there. So huge pumps in the upper Waterton Lake, pulling lots of water out of the lake and through massive hoses. We have pictures. They might be on our website on the Kenow fire page that shows a lot of the preparation work that was done. But yeah, absolutely massive hoses and sprinklers wetting that area down. So those two efforts combined are what made the difference that night. And if those two things hadn't happened, then the town site very likely would have been damaged very significantly by the fire. So fire preparation is really, really important wherever you live. So just something to think about. There's a really great website called firesmart.ca that has a lot of information about preparing for wildfire in case it happens. And I encourage anybody to take a look at that and learn.
Super. I guess one question I have, in a sense, certainly I hope we all get a chance to visit Waterton, certainly next year for sure. I'm just wondering, what's the safety issue related to all those trees standing? Is there a concern? Because, as you know, Waterton is a windy environment. Is there been some work done on the safety of the trails that people may want to go on?
Good question. So immediately following the fire, that was one of the things we started working on, was assessing. It's called a hazard tree assessment and reduction, or removal. So we have a trail crew in place. We actually hired crews to come in. Glacier National Park, our fellow Peace Park neighbor, sent crews up to help clear some trails and other areas of hazard trees that had been damaged in the fire. So a lot of that work has happened along the roadways and all the campgrounds and all the day use areas, and along the trails. Our trail crew continuously is working on that every season. So when you come to Waterton, you can know that work has been done, and that hazard trees are continuously looked at and removed where needed.
Super. I hope to be there next year for sure. Anyways, Kimberly, I think that brings us to the end of the questions here, other than the fact that it was a great presentation. One just popped up. I don't know if we got time just for that. Is Glacier Park, was it affected by the fire as well?
Yeah, no, it was not. This fire took place entirely within Canada, but there was another fire that happened in 2018. It was called the Boundary Creek Fire, and it started in Glacier National Park, just across the boundary on the west side of the lake. So immediately adjacent to the Kenow fire. It burned mostly in Glacier National Park in the Boundary Valley area, but it did move into Waterton a little bit as well. And I'm glad you brought that up because that fire was a lot smaller. It happened over a longer period of time. It wasn't quite as extreme in its behavior, but it did have extreme impacts as well on the landscape because it was similar sort of conditions. And so when we look at the area affected by fire in the park, we actually include that smaller area that was affected by it. But yeah, it did also impact Glacier.
Great, thank you. I guess the end. Thank you very much on behalf of Nature Calgary for such a great presentation on an area that we dearly love to visit and to explore. So I thank you very much for all your efforts in trying to keep our little corner of the world safe in that sense, at least understand what's going on, you and your colleagues. And
Yeah.
yeah, so very, very great presentation.